Bam! Mr. Tarrou. In this video, we're going to be doing 3 examples of solving natural exponential equations, or just continuing our journey through working with logarithms. When you have an equation with a variable in the exponent, it's more than likely going to require logarithms to solve for that unknown. And there's many lessons that I have for logarithms. You'll find a link to all of those common logs, natural logarithms, log base 2, where you're changing the base of those logarithms in the description of this video. And you're also going to find timestamps to the 3 examples that I'm going to work through. In case you want to, get to a harder example, I'm going to show you how to work out this problem 2 ways. You can skip ahead to any of those 3 examples that you like, and they will increase in difficulty as we go. So the first example we have here is 5 times e to the negative 3t power is equal to 3. Now, I'm assuming if we're talking about solving these natural exponential equations, or just solving equations that require logarithms, you already understand that when you take the log of a number, you get an exponent. So exponential functions and logarithms are inverse math operations. So here we've got 5 times e to the negative 3, t is equal to 3. We want to isolate that base that has the variable in the exponent so that we can then apply the inverse math operation. So we're going to undo this multiplication of 5 with the division. Let's grab some orange chalk here to show our work. We're going to divide both sides by 5. That's, of course, going to give us e to the negative 3t power is equal to 3/5. And now we're going to apply that inverse math operation. Exponential functions, logarithmic functions are inverse math operations. I look at that relationship very detailed when we talked about graphing natural or logarithmic functions. Link to that video in the description as well. So we're going to apply the natural log function. Now I'm pausing. You've got to get, if possible, that mathematical function that you're trying to undo with the inverse math operation alone. So we're going to, now that we have, take the natural log of both sides of our equation. So we have the natural log of e to the negative 3t power and the natural log of 3/5. Well, that's obviously an exponential function with base e. Natural log is log base e. And since these inverse math operations have the same base, they will cancel each other out as long as they're sort of right next to each other, applied right next to each other. We're going to have negative 3t is equal to the natural log of course, 3/5, and then we just have to divide both sides by negative 3. And we have t is equal to negative 1/3 times the natural log of 3/5. Now, you're taking a multiple choice test, or you're looking in the back of the book to check your answers. And this is a pretty straightforward question. You've only got one base e, one natural exponential function in our equation, but yet this is not the answer in the back of the book, or one of the choices maybe on a multiple choice test. But you look and you see something very similar. Maybe you see this as an answer. So have we made a mistake? We have a division of 3, so do I. Basically, we have the natural log of a fraction dealing with a 3 and a 5. We have the natural log of a fraction dealing with a 3 and a 5. But what the heck? How do you go from here to maybe this answer if you're using like a CAS calculator, or again, you see multiple choice or back of the book? Well, remember that we have that power rule for logarithmic functions, and we can write this as negative natural log of, again, 3/5. I'm just going to kind of write this closer to this format, over 3. And now, with that power rule that we have for logarithms, we can take that coefficient of negative 1 and move it up as a power. And that is going to be negative's coming up. We're going to have natural log of 3/5 to the negative 1 power over 3. Well, if you want to rewrite this so that you don't have that negative exponent, kind of like, x to the negative 2, well, you just take that base that the negative 2 is applied to, and flip it, and you get 1 over x squared, or maybe you're used to seeing it like this. If you have a base with a negative exponent, you can take that base and move it into the denominator and get 1 over x squared. Well, the same thing's happening here. Because just the process and the way that we work through our problem, got that negative 1/3 natural log of 3/5. That negative can be shown as a coefficient of -1. We can bring that up and we can write this, take this, the base that has the exponent of -1 and write the reciprocal. Well, that's going to turn what was our negative exponent into a positive one. So a little bit there, because sometimes with multiple choice tests we can get a correct answer, but then get a little bit confused when we go to check our work or try and choose, is it A, B, C, or D, or again, just simply checking our answers in the back of the book and not seeing exactly the same thing. A lot of times we might have actually done the right work. Over here with example 2, we have e to the 2x minus 6 times e to the x minus 7 is equal to 0. And how are we going to solve this? Well, we've got 3 terms. We've got a first exponent, which is twice as big as the second exponent, and then we don't have sort of that exponent showing up at all. Now, e is not an exponent, but we have a variable in the exponent. The pattern, though, right? This is going to solve just like this question. Here's some kind of common base, but I'm going to write x instead of e, just showing you the relationship of something you've learned in the past. It's a little bit similar. I'm going to put a power of 2, and then I'm going to write minus 6x, but now I'm going to have a power of 1, right? Which I don't even need to write. So minus 7 is equal to 0. This quadratic, how you solve this quadratic in Algebra 2, and maybe even near the end of Algebra 1, is the same thing. We have a base of e and a base of e. We have a base of x and x, only here it's a variable as opposed to a constant. We have 2x is twice as big as 1x. Well, we have an exponent of 2, which is twice as big as an exponent of 1. And then you have that constant here, and it's equal to 0. This is actually a factorable quadratic in disguise. So let's go ahead and highlight the fact that we have a coefficient of 1 in front of this e, just like we have a coefficient of 1 in front of this x, and talk about factoring. With a coefficient of 1 on a quadratic, you just have to look for factors of the constant that add to the middle term. Well, of course, that's going to be x minus 7 times x plus 1. And then now that it's factored, you set each factor equal to 0 and you continue. Well, that's exactly what we're going to do here. We have a coefficient of 1. We have an a, basically. We have sort of a b, a middle coefficient of -6, and we have a constant of -7. So we can factor this as 1e. Now look at here. We have x to the first, right? Because x times x is x squared. So when you multiply like bases, you add the exponents. And kind of in reverse, if you want to think of, well, that's x times x is x squared, I'm kind of square rooting. So when you square root something, you divide that exponent by 2. So when we see that we have e to the 2x and we notice that quadratic pattern, we're basically sort of square rooting this, and well, not sort of, we are. The square root of x squared is x times x. So square rooting is, your rational exponents, it's power over root. So square rooting is dividing by 2, and 2x divided by 2 is just equal to x. So we have e to the x and e to the x. And with our leading coefficient of 1, we're just looking for factors of -7, of course, that add that middle coefficient. So -7 plus 1 is equal to 0. And now that we get our equation in factored form, we just set each factor equal to 0. Well, our inverse math operations are going to cancel out. So log base e and exponential function base e. So these inverse math operations cancel. We just have x is equal to the natural log of 7. Now because this isn't like an introductory lesson to logarithms here, so if you look over here, you might already know the answer, but for those of us maybe that struggle a little bit, we have the natural log of -1. Well, logarithms give exponents, and this is log base e to the negative 1, and logarithms are another way of writing an exponent. So we're looking for some kind of exponential answer, you know, like e to what power is going to give you negative 1? Well, I'm sorry. You're not going to take a positive base, right? Exponents are just how many times you repeatedly multiply by that base. E is approximately 2.718. It's a positive number, and with logarithms, those bases always have to be positive. Otherwise, you get a graph that kind of just oscillates as you talk about, you know, you've never graphed an exponential function with a negative base. It just doesn't work. There's lots of reasons and way of explaining that. So that base always has to be positive, and you're never going to take a positive number, repeatedly multiply it by itself, and get a negative answer. So this is undefined, and that is the end of our second example. But now wait a minute. What if I had given you this quadratic pattern, 3 terms, kind of like an exponent which is twice as big as the middle exponent, and then there's no variable or that sort of common base showing up at all in the third term? What if that wasn't factorable? Well, of course, you know that if you have a quadratic from Algebra 1 or Algebra 2, all those skills just keep coming back, that you can use that quadratic formula, which, by the way, is just derived by completing the square, something else you learned in Algebra 2. But at any rate, if that was not a factorable equation, you could just identify A as being 1, B as being negative 6, C as being negative 7, and, well, that quadratic formula is x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. But this was the quadratic formula for solving, you know, quadratic equations, like something like x squared minus 6x minus 7 is equal to 0. Well, see, here our common base is x, and here our common base is e to the x, right? We have an x and we have an x. Of course, it's to the first one as big. This is to the x, something twice as big. Our common base is e to some power. So I say that because we're going to have to, I can't just write e here. It is e to that variable x. And so instead of writing x, I'm just going to write e to the x. No, I just wanted to show you that because, you know, not every problem like this in your homework is probably going to be factorable. And so again, A, B, C, plugging into the quadratic formula, of course, e to the x, not x, again, because of that base. Working this out, and you can see that we ended up at the same place. E to the x is equal to 7, e to the x is equal to negative 1, and, you know, we're going to finish that up and get, of course, the same answers. So don't get stuck on the idea that all of these questions work out exactly the same way. Keep pulling on all those skills that you have learned in Algebra and Algebra 2 as you're working through your rest of your Algebra 2 class, maybe pre-calculus, maybe calculus, you know, whatever. All of these skills, you got to keep them in your toolbox. They keep coming back. And for our last example, we have e to the 3x plus 1 is equal to 6 times e to the 1 minus x. Great. How do we work this out? Well, if the 6 wasn't there, then you could just go, well, both sides have a base e, so if the bases are the same, the exponents have to be the same, and just write 3x plus 1 equals 1 minus x and solve that linear equation. But there is a 6 there, so what do you do? Okay, well, how about we try this? Exponential functions and logarithms are inverse math operations, so let's just go ahead and apply the natural log to both sides of this equation and see what happens. Well, over here, the natural log function and the exponential function, they just simply cancel out, and you have 3x plus 1. Now over here, the natural log function and the log base e and the natural exponential function, e to the 1 minus x, those inverse math operations are not going to cancel out because they're kind of like not, directly applied to each other. There's this darn 6 in the way. Well, remember that logarithms are exponents. So all those properties of exponents you learned in previous lessons and maybe last year or whatever courses you're in, that when you multiply with a like base, and our like base here is base e, when you multiply with like bases, you end up adding the exponents, and logarithms are exponents. So we can rewrite this, recognizing that we have a multiplication within a same base as the natural log of 6 plus the natural log of e to the 1 minus x. Well, look at here. The natural log function, the log base e, and this exponential function base e, now these math operations are right on each other. They're applied right directly to each other, and those inverse math operations will cancel out. And we have 3x plus 1 is equal to the natural log of 6 plus 1 minus x. Okay, so let's subtract both sides by 1, and that's just going to simply cancel out. And we're going, except I missed, there we go. And then we're going to add x to both sides. And we get 4x is equal to the natural log of 6. And then we can undo this multiplication with division and get our final answer of x is equal to 1/4 natural log of 6. Now, funny thing is, I already had this example done on my paper for this video, and this is actually not, what I did. I didn't, for some reason, think about the idea that I could take this multiplication inside the logarithm and expand the logarithm and solve it this way. So, since I've done the example now 2 different ways, why don't I show you? Again, just letting you see that the more skills you have and the more you work with these problems and become comfortable with, really not these problems, but just all of math. I teach everything from Algebra 1 all the way through calculus. So you start to see how so many concepts you learn repeat and come back, and they look a little bit different maybe, but they're still applicable. So if it really confuses you or stumbles you that this e has some kind of coefficient on it, you could do this and go, well, let's try and separate a different way. When do you add in your exponents? Like you have e to the 3x, and then within that exponent, you have an addition of 1. Well, when do you add exponents? You add exponents when you multiply like bases, right? So you could write this as e to the 3x times e to the first, and on the other side of this equation, we have 6 times e to the 1 minus x. Well, when do you subtract exponents? You subtract exponents when you divide like bases. So this is coming from e to the first divided by e to the x. So I have a variable in the denominator, and you can't solve for a variable when it's in the denominator, so let's undo that. We have a division of e to the x, so let's multiply both sides. Oh, chalk down! Let's multiply both sides by e to the x. And, anything divided by itself cancels out. We have e to the x times e to the 3x. When you multiply like bases, you add the exponents. I'm not going to be doing some kind of distributive property here. I kind of am distributing, but there's only one term in here, not like a plus sign, so you don't have 2 terms. You don't multiply twice. So you have e to the x plus 3x times e equals 6 times e. Of course, that's 1x plus 3x is 4x. And when solving equations, you never want to divide away a variable, but because you'll lose some of your answers. You'll maybe get some of the solutions, but not all of them. But what I'm going to do here is I'm going to divide both sides by e, because e is not a variable, right? It's a constant. It's approximately 2.718. And now we have e to the 4x is equal to 6. And I'm getting really close to where I was over here. How do you undo that natural exponential function? You take the natural log of both sides. So we have the natural log of e to the 4x is equal to the natural log of 6. these inverse math operations one more time, undo each other, and you get 4x is equal to the natural log of 6, and I do believe that's what I had up here. You see it starting to tie together, and we get the same answer. So the more skills you have in your toolbox, the more ways you can look at solving these equations. I'm Mr. True. Bam! Go do your homework.